Hello everyone, myself Darshan from Sri Venkateswara College of Engineering. Subject COA. Topic floating point representation and IEEE standards. Introduction to floating point representation. Floating point representation is a way to encode real number in a in a format that can represent a wide range of values. It allows for the representation of very large and very small numbers by using a scientific notations like format. This method is crucial in computing for tasks that require high precision such as scientific calculations and graphic rendering. Components of floating point numbers. Floating point numbers consist of three main components: the sign, the component, and exponent, and the significand. The sign indicates whether the number is positive or negative, while the exponent determines the scale of the number. The significand provides the actual precision of the number, representing the significant digits of the value. IEEE 754 Standard Overview. The IEEE 754 standard is the most widely adopted standard for floating point representation in computers. It defines various formats for representing floating point numbers, including signal, single precision, and double precision. This standard ensures consistency and accuracy in numerical computation across different computing systems. Single precision format. Single precision uses 32 bits to represent a floating point number consisting of 1 bit for the sign, 8 bit for the exponent, and 23 bits for the significand. This format allows for approximately 7 decimal digits of precision and a range of values from about 1.4 into 10 to the power minus 45 to 3.4 into 10 to the power 38. Single precision is often used in applications where memory efficiency is critical, such as in graphics processing. Double precision format. Double precision uses 64 bits for representation, allocating 1 bit for the sign, 11 bit for the exponent, and 52 bits for the significand. This format provides approximately 15 decimal digits of precision and a much larger range of representable values. Double precision is commonly used in scientific computing where higher accuracy is required. Special values. The IEEE 754 standard defines special values such as NaN, not a number, positive infinity, and negative infinity. NaN is used to represent undefined or unrepresentable values such as the result of dividing 0 by 0. Positive and negative infinity are used to represent overflow conditions or limits in calculations. Rounding modes. Rounding modes in IEEE 754 determine how floating point numbers are rounded during arithmetic operations. The standard simplifies several rounding modes, including round to nearest, round towards 0, and round towards positive or negative infinity. The choice of rounding mode can significantly affect the result of computations, especially in iterative algorithms. Precision and accuracy. Floating point representation inherently involves trade-offs between precision and range of values. Errors can accumulate in calculation due to rounding, leading to precision loss, commonly referred to as floating point errors. Understanding the limitations of floating point. Arithmetic is essential for developers to avoid inaccuracy in critical calculations. Application of floating point representation. Floating point representation is extensively used in various fields including graphics, scientific simulations, and financial calculations. It enables real-time rendering in computer graphics and simulation of complex physical systems in science. The ability to handle a vast range of values makes it essential for developing robust and efficient software application. Conclusion. IEEE stands for Floating Point Representation, play a crucial role in ensuring consistency and reliability in numerical computations. Understanding how floating point numbers work helps developers create more accurate and efficient algorithms. As technology advances, continuing to define and adapt these standards will be essential for future computing needs. Thank you.